The last time a human being traveled beyond low Earth orbit, Richard Nixon was president, the Vietnam War was still being fought, and the most powerful computer on Earth had less processing power than the phone sitting in your pocket right now. That was 52 years ago. And everything is about to change. Here's something most people don't fully appreciate. Since December 1972, when astronaut Gene Cernan climbed back into the lunar module and became the last human to walk on the moon, every single human being who has ever traveled to space has stayed within roughly 250 miles of Earth's surface. The International Space Station, 250 miles up. The Space Shuttle, same. Every astronaut, every mission, every historic moment of the last 5 decades. All of it happening in what scientists call low Earth orbit. A thin shell of space so close to home that proportionally, if Earth were the size of a basketball, those astronauts never even left the fuzz. But the human species was never meant to stay in the shallows. In 2022, NASA launched Artemis 1, an uncrewed test of the most powerful rocket ever assembled. No humans aboard, just data, systems checks, and a taste of what was coming. It worked. And now they're sending people. 4 human beings are about to strap themselves onto 5.7 million pounds of thrust and ride it to the edge of the known world. Commander Reid Wiseman is a decorated US Navy test pilot who logged over 165 days aboard the International Space Station. Cool under pressure, technically brilliant, the kind of commander you want, making decisions 250,000 miles from the nearest hospital. Pilot Victor Glover made history in 2020 as the first black astronaut to live aboard the ISS for a long-duration mission. An accomplished naval aviator with over 3,000 flight hours, Glover isn't just flying this mission, he's redefining who space belongs to. Mission Specialist Christina Koch already holds the record for the longest single space flight by a woman, 328 consecutive days in space. She brings deep space resilience this mission demands, and she will become the first woman to travel beyond low Earth orbit, ever. Mission Specialist Jeremy Hansen is a Canadian Space Agency astronaut and fighter pilot. This will be his first space flight, and he is set to become the first Canadian to venture into deep space. 4 people, 1 spacecraft, 10 days, and a journey that will take them farther from Earth than any human has traveled since the Apollo era. Now let's talk about the machine making it possible. The Space Launch System, the SLS, is NASA's most powerful rocket since the Saturn V. Standing 322 feet tall, taller than the Statue of Liberty, it burns liquid hydrogen and liquid oxygen through 4 RS-25 engines. On either side, 2 solid rocket boosters, each taller than a 17-story building, provide an additional 3.6 million pounds of thrust at liftoff. Together, the SLS generates over 8.8 million pounds of thrust in those first critical seconds. It is the only rocket on Earth currently capable of sending humans toward the moon in a single launch. Riding on top is the Orion spacecraft, where our 4 astronauts will live for 10 days. At 316 cubic feet of habitable volume, now it's roughly 2.5 times the living space of the Apollo command module. It carries advanced life support systems, modern computing and touchscreen interfaces, dedicated radiation monitoring, and a European service module built by ESA that provides propulsion, power, water, and oxygen for the entire journey. And then there's the safety system nobody wants to use, but everyone is grateful exists, the launch abort system, a tower of solid rockets at the very tip of the vehicle, capable of pulling the Orion capsule away from an exploding rocket in milliseconds. It can detect catastrophic failure, fire, and carry the crew to safety before human reaction time could even register what happened. Launch day. The rocket has been fully fueled in the hours prior. Liquid hydrogen chilled to minus 423 degrees Fahrenheit. Liquid oxygen to minus 297. Frost forms on the exterior of the vehicle in the Florida heat. The RS-25 engines ignite 6 seconds before liftoff. Building thrust, running real-time systems checks. Computers confirming, go, go, go. The solid rocket boosters ignite, and 5.7 million pounds of metal, fuel, technology, and 4 human lives leave the ground. In the first 2 minutes, the solid rocket boosters burn through their entire fuel supply and fall away into the Atlantic. At 8.5 minutes, the core stage separates. The interim cryogenic propulsion stage fires, pushing Orion into a stable parking orbit around Earth. And here, in low Earth orbit, the crew performs a full systems check. Because this is the last off-ramp. After the next burn, they're going to the moon. The translunar injection burn fires, accelerating Orion beyond Earth's orbital speed and sending it on a trajectory toward the moon. The journey takes approximately 3 to 4 days, and it isn't spent floating weightlessly through adventure. It's spent working. The crew follows a rigorous daily schedule. Systems testing, because Orion is still partly a test vehicle, and every anomaly is documented and relayed to Earth. Medical monitoring, NASA needs to understand in real time how human bodies respond to deep space radiation, fluid shifts, bone density changes, and sleep disruption. Manual piloting drills. In the event of a communication blackout, the crew must be capable of flying Orion themselves. And through the windows of their spacecraft, they observe Earth growing smaller behind them. There is a well-documented phenomenon called the overview effect, a cognitive shift experienced by astronauts who see Earth from deep space. Small, fragile, unified, borderless. Apollo astronauts described it as transformative. Artemis 2 will formally study this effect for the first time. On approximately day 4, the crew arrives at the moon, and Artemis 2 will not land. This is not a lunar landing mission. Instead, the crew performs what's called a hybrid free return trajectory. Using a precisely calculated burn near the moon, Orion swings around the far side, the side that never faces Earth, where all communication with the ground goes completely silent, and uses the moon's gravity as a slingshot, looping the spacecraft back toward home. The genius of this trajectory is its elegance, even if the engine fails completely. So the moon's gravity itself curves Orion back toward Earth, a safety net built directly into the laws of physics. But here is the moment that stops you cold. When this crew rounds the far side of the moon, they will be approximately 270,000 miles from Earth, farther than Apollo 13 during its emergency, farther than any of the 12 men who walked on the lunar surface, farther than any human being who has ever lived. And in those minutes behind the moon, cut off from all communication, beyond every signal, surrounded by total silence, 4 people will be the most alone that any members of our species have ever been. That is not a small thing. If launch is the most dramatic moment of this mission, re-entry is the most dangerous. After 10 days, Orion is hurtling back toward Earth at approximately 25,000 miles per hour, Mach 32, saying 32 times the speed of sound. When the spacecraft hits Earth's upper atmosphere at that velocity, the air in front of it cannot move out of the way fast enough. It compresses, and compressed air heats rapidly, violently, until temperatures on the heat shield face reach approximately 5,000 degrees Fahrenheit, half the temperature of the surface of the sun. During this phase, ionized plasma surrounding the vehicle blocks all radio signals. Ground teams lose contact. The crew is completely on their own. The Orion heat shield, the largest ever built for a crewed spacecraft, is made of an ablative material called avcoat, designed to burn away in controlled layers, carrying the heat with it. The crew inside experiences intense deceleration, several G's of force pressing them into their seats. Then the drogue parachutes deploy. Then the 3 main parachutes, each as wide as a football field, slow the capsule to splashdown speed in the Pacific Ocean. 10 days, approximately 590,000 miles traveled. The farthest humans have gone in over half a century. Mission complete. Now, why does this actually matter? Artemis 2 isn't the destination, it's the foundation. Artemis 3 will be the first crewed lunar landing since 1972, targeting the moon's south pole, where permanently shadowed craters are believed to contain billions of tons of water ice. Ice that can be converted into rocket propellant, drinking water, and oxygen. The lunar South Pole isn't just scientifically fascinating. It's potentially a fuel depot for everything that comes next. Then comes Lunar Gateway, a small space station in lunar orbit, a way station between Earth and deep space. And beyond that, Mars. Everything NASA is building right now, the SLS, Orion, Gateway, the lunar South Pole infrastructure, it's all a highway, built not for one trip, but for generations of journeys. There are moments in history that everyone, in retrospect, agrees were turning points. The Wright brothers at Kitty Hawk, Yuri Gagarin breaking the atmosphere, Neil Armstrong on the moon. In the moment, people often don't fully grasp the weight of what they're witnessing. History only reveals itself in hindsight, but sometimes you can feel it coming. 4 people, 1 spacecraft, 10 days. And for the first time in 50 years, humanity reaches beyond the comfortable, familiar edge of home. If this video gave you chills, drop a comment below and tell me, which part of this mission blows your mind the most? The crew? The engineering? So the moment they go farther than any human in history? Or what comes after? Artemis 3, Gateway, Mars. I read every single comment. Tell me. And if you want to understand what's really happening in science and space, not just the headlines, but the real story, subscribe and hit the bell. The next video goes somewhere even bigger. You don't want to miss it. Humanity is going back to the moon, and this time, we're not leaving.